Good morning, one and all. Hi, I'm Vishal. I'm from Triple E Engineering third year. So I'm here to explain about efficient computation of maximum loading point by load flow method with optimal multiplier. So from a base operation point, the computation of the maximum load point MLP is to determine the amount of additional load in a specific increase pattern which would drive a power system to the point of collapse. Continuation methods, direct or point of collapse POC methods, and optimization techniques are intensively studied and widely used to obtain the MLP. This latter presents a new method based on the Newton-Raphson the load flow with optimal multiplier OM optimal multiplier OM in rectangular coordinates coordinates. So here the OM load flow method was first developed by Iwamoto and Tamura for ill-conditioned systems. The OM load flow method was produced by Iwamoto and Tamura for for the ill-conditioned systems. The performance compared to the OM load flow using polar and rectangular coordinates in detail. The OM load flow was used by under unsolvable system conditions. In the research of Zarath, it was employed to compute the MLP starting from the base case in polar coordinates. Dissimilarly, the proposed method in this study starts from an infeasible point behind power system maximum loadability. F of x comma gamma is equals to f of x minus s is equals to 0. S is equals to s naught plus lambda b. So here where it's the nodal power injection vector at base case and represents the change in reactive real and reactive power load demand and the change in real power generation at the MLP, and the Jacobian matrix usually becomes singular. Here the Jacobian matrix becomes singular and the change in real and reactive power load demand and the change in real power generation happens. So this MLP is associated to saddle this MLP is associated to saddle node bifurcation. The proposed method find a solution satisfying first and then updates using. Suppose at the MLP it the uh, the proposed method found a solution which suppose at the MLP that is equal to for a given initial parameter. We try to solve the load flow by the NR load flow method with OM in rectangular coordinates at ith iteration. The update vector is multiplied by an optimal multiplier. So here we can see x of k plus 1 is equals to x of k plus u into delta x of k, where u mu is chosen to minimize the norm of load flow mismatch vector in the direction given by delta x of k. Since lambda naught greater than lambda naught has no solution, it has been proven that mu will decrease to 0 during the iteration process. So the iteration becomes trapped at a point x. The corresponding Jacobian matrix is singular with this loop decomposed matrix. The left eigenvector omega naught as associated with its 0 in eigenvalue can be calculated efficiently using the inverse power method. So j of x is into delta x minus delta by b lambda b is equals to f of x naught minus s naught minus lambda naught b. Left multiplying both sides of phi with omega t and considering the following equation is derived omega delta lambda omega tb plus omega t s naught plus lambda naught b minus f of x naught. S naught plus y naught lambda naught b minus f of x naught is actually the mismatch vector of the load flow. The correct formula for lambda is lambda y is equals to omega power of t s naught plus lambda naught b minus f of x naught omega tb. For different, the MLPs are different. All these MLPs in the parameter space of compose a hyperspace surface, which is usually denoted by is generally convex. More precisely, most of its part is convex. Hence, after updating by generally still has no solution. By repeating the above mentioned procedure, we can approach the MLP defined by the given illustrates. The first iterative step, the axis and the are two elements of steps to obtain the MLP are summarized as follows. Set and the convergence tolerance solved using the load flow method with ohm. If the load flow converges, let go back to step otherwise and the other obtained. Calculate the normalized left eigenvector rated with the zero eigenvalue of get if by and correct with the stop iteration. Otherwise let and then go back to step was designated to deal with the small initial guess of the load parameter and non-convex portion. So, if an MLP corresponds to a limit-induced bifurcation, the NR LIB, the NR load flow method with OM will neither become trapped at a point nor converge when it is very close to the MLP. The mismatch vector's value of the load flow equation is oscillates periodically. At least one of the generator buses switches from PV type to PQ type and switches back repeatedly. These generator buses are recorded by the load flow computer program. Choose one of the recorded buses. Set the generator's reactive power output at its limit. So, the proposed method has been tested for several IEEE test systems and a real 682 bus system. Here is set to equal to 10. The generator reactive power limits are considered. Results are listed in table 1. The values in the columns titled refer to the number of iterations, while the last two rows show the results of the continuation and the POC methods that were calculated by UWP of LOW. The UWP flow. The results obtained by the proposed method are almost the same as those by the PUC method and are more accurate than those by continuation method. The proposed method converges after only several iterations and even is much larger than computation times for the 682 bus system are listed in the last row of table 1. The average computation for the bus base case load flow is 0.187 s. The average time required per iteration of the proposed method is less than 1.5 times of its smaller than 0.5 figure. Shows the convergence process of tests on the IEEE 57 bus system under different initial values. The MLP associated with an LIB is encountered when testing the proposed method on the IEEE 180 bus system. Test results are shown in the table. The POC method fails to converge and no results are given. Here, the values in the third column of table stand for the iteration times of the proposed method to identify that the MLP corresponds to an LIB. In each of the last iterations, the NR load flow program records that 5 generator buses 130 switches are from PV type to PQ type and vice versa repeatedly. Then 8 are formed and solved. The reactive power limit to generator bus 10 reduces the bifurcation. The differences of the computation times shows in this graph. We can see that the number of iterations, how it is happening from 0.1 to 1 to 10. They are gradually decreasing. In the table we can see the 3 in the third row. It is a iteration process. So MLP associated with an LIB is encountered. So we can see here. Thank you so much.